Hey guys, and welcome back. So in the last video, what we did is we took our service controller with one or two pods, and we configured it to be exposed exclusively on the internal cluster network that you configure when you deploy a Kubernetes cluster. So now what we want to do is to take a look at the last option that we have for exposing services. And of course, that's exposing services through what's known as a load balancer. Now, the load balancer itself is actually going to belong to your VPC. So even though I don't really have enough space to kind of show that in this particular diagram, the load balancer does belong to this VPC, and it'll basically sit side by side with the pod network interfaces, and the service controller that we create of type load balancer is basically going to take these network interfaces that the pods are connected to, and it's going to expose those as targets for the load balancer over here. So let me actually move the load balancer over to the right-hand side here. And so these network interfaces would basically get registered with this load balancer, and then anybody who wants to access the service that's running on these pods here, thanks to this service controller, will then have to route their traffic through the load balancer, and then the load balancer will pick one of those targets behind it to route the traffic to. Now, for starters, before we get too far ahead, if we were to come over to the EC2 console here and drill down to load balancers under the load balancing section here, you should see that we do not have any load balancers configured for this particular VPC. So we do have a couple load balancers here, but these belong to VPCs 0A0 and 096. But if I was to take a look at my VPC console, the VPC ID of my floral painting is actually 0D5. So the other load balancers actually belong to these other kind of orphaned clusters that I've used previously. However, my current VPC 0D5 does not have any load balancers allocated to it. And so basically what's going to happen is when we create the service controller, it's going to dynamically provision a load balancer on our VPC 0D5, and that will allow us to forward traffic through that load balancer in order to access the service running in our pods. So let's go ahead and do that now. So I'm going to come back to my terminal here. Let me close my little test VM over here. And then I'm going to exit out of this PowerShell test pod that we were using previously. And let's just do a quick kubectl get all just to see what we currently have in our networking namespace. And I think we should have an orphaned service here that we used from the last video, and we do have a few pods up here. So I'm just going to say kubectl delete pod cluster IP pod and pod nginx2 and the PowerShell pod that we don't need any longer as well. Let's do delete pod nginx2 and pod PowerShell and service cluster IP service. So that should bring us back to more or less a clean slate. I think I could do kubectl delete all as well. I think there's a shortcut to actually just kind of clean out all your resources. But now what we need to do is go ahead and spin up a new pod for this use case. Let me just do a quick kubectl get all, make sure everything is cleared out here. All right, there's nothing there. And we'll do a kubectl run, and we'll use the nginx image again. We'll expose it on port 80, and we'll give it a name like pod nginx 1. And let's also give it a label. We'll say label equals, let's do type equals load balancer. And of course, the correct parameter name is actually labels. So let's fix that, put an S on there. And it looks like it doesn't like the name here. That's because I prefixed it with the resource type. So let's go ahead and spin that up. And then I'll spin up a second one, and maybe just for fun, we'll do a third one as well. So now what we're going to do is create another service, and we're of course going to use the selector of type equals load balancer. However, this time what we're going to do differently is we're going to create a service using the type of load balancer. So let's do load balancer, and of course we need to give that service a name as well. So let's call it my LB service, and of course we need to plug in our port forwarding rule as well. We'll do TCP equals, let's say, port 36,010, and we'll forward to port 80 on our pods. And if we do a kubectl describe service, or SVC for short, you can do as an abbreviation, we do need to update our selector to use the type equals load balancer. So let's do that really quick. We'll do kubectl set selector service slash my LB service, and we'll do type equals load balancer. And then we'll go ahead and just verify that really quickly and make sure that it's been updated. And sure enough, it has. And so at this point, you can see that within a matter of seconds, the service controller has detected that there are 3 matching endpoints based on the selector that we chose here. So now what we can do is hit that load balancer from the outside. But before we do that, let's come back to the EC2 console here and just do a quick refresh. And you'll see that we have a load balancer that was created today, Valentine's Day, February 14th. And if we take a look at the details for that load balancer, you'll see that it has an external DNS name. Now, if you'd like to access your application on a different DNS name, you can go to your DNS provider and you can create a CNAME record, which is short for canonical name, and you can basically configure that canonical name record to forward traffic to this DNS name as the target. So that's how you can kind of rename your service rather than having to publish this bizarre auto-generated DNS name. So once that load balancer becomes active, which can take a little bit of time, we should be able to hit this service by plugging in this DNS address. However, keep in mind that we chose a somewhat random port for the outside of our load balancer, and it looks like it actually allocated port 31865 as the node port. However, the actual port that we'll hit the load balancer on is going to be 36,010. So let's go ahead and open up our browser, and then we'll plug in the DNS name followed by port 36010. And sure enough, you can see that after just a couple of minutes here, once that load balancer is active, the load balancer is actually forwarding traffic over to our pods successfully. And so at this point, because the service controller is actually rotating across these different endpoints right here, if we were to kill off one of those endpoints, our service would continue to run. So let me do a kubectl delete pod, and we'll just delete nginx2 kind of randomly. And then if we just hit up arrow a couple of times and do another describe on it, you'll see that the service controller immediately became aware that one of those pods has now disappeared, and so the endpoints have now been updated to exclude the pod that has now been deleted. And so if we come back to our browser and just continually hit Control-Shift-R to force a refresh, you can see that our service is still up and running. Now, the only way that we could really kill things off is to actually kill all of the pods that are backing that service. So if I kill off pods nginx 1 and 3 and then come back to the load balancer, you'll see that it is going to fail, because even though the service controller is still technically up and running, and the load balancer, of course, itself is up and running as well, there are no actual pods running behind that load balancer to serve up any kind of traffic. And you can see if we describe the service, sure enough, under endpoints here, there are none. There are no endpoints that this service controller could send traffic to. So we could very easily remedy that situation by simply creating a pod with the appropriate label that matches the selector on the service. And if we come back over to our browser, now you can see that we are immediately able to make requests back to that service. So that's how the load balancer service type works in Kubernetes. I hope this has been informative for you, and I'd like to thank you for viewing.